Hello, in this lesson, I'm going to review types of variable and levels of measurement. Now, that was one of the most common mistakes in the first in-class handout. So let's do it. So data information that we collected in our study. It could be from an experiment, it could be from an observation study. So, the characteristic things that we collected. So data, there's two types of data. One is qualitative, one is quantitative. So quantitative on this side. So it's been two different categories. Now for quantitative data, is numeric in nature. For example, are like height, weight, elapsed time, distance traveled, age. And for quantitative data, this can also split it into two separate groups. So there's a discrete data. Discrete data, things that you usually generate count to get, like countable or finite. There's a gap in values that are possible. So examples are number of people in a class, shoe size, another one. So for example, for women's shoes, you have size 5 and a 5.5. You have a size 6, but there's no shoe size in the US that's between 5.5 and 6. So those are discrete data. Now, quantitative data, another group of quantitative data is continuous data. Now, continuous data here is uncountable or infinite. There's no gap, right, in the value that are possible. Things that you generally measure or calculate to get. Like say, this one here could be calculation to get. Now, such thing, if for example, there's a distance traveled to school, those are continuous variable. Now, another type of data is qualitative data. Now, for the qualitative data here, is categorical in nature. Examples are gender, eye color, political party, car type, age group. Now, one common mistake that I've seen in one of the first exam I gave last time was a zip code. Right, zip code a lot is also qualitative. Now, even though it's number, for example, zip code 90034. It tells me the location, geographic area. It doesn't, I can't really add zip code or subtract zip code. It doesn't make sense. So this is qualitative, right? And this one, for example, here describes a specific location of zip code, which is my home, right? So that's in Los Angeles, West Los Angeles. So zip code is qualitative data. Now, let's before move on, that's not a common mistake. That's one of the common mistake. Students think of this as continuous. Next one is common mistake is in the last assignment. A student tell me, hey, this example, this one is qualitative data and is continuous. Wait a minute. Qualitative data cannot be continuous or cannot be discrete either. It doesn't make sense to say that discrete or continuous here. So be very careful here when you say, is qualitative or quantitative. Quantitative data can be discrete or continuous, but it does not make sense to say qualitative data is continuous discrete. So cannot, it doesn't make sense to say one qualitative data is continuous or discrete here. So be very careful. All right, next group, let's review levels of measurement. Now, there's two big groups here. First group is level measurement for categorical data or qualitative data. This is either nominal or ordinal. Now, nominal, the category do not have an inherent ordering system. Right? The category cannot overlap. Each piece of data can only fit into one category. So examples are eye color, like blue, brown, hazel. Another example, answer type, yes or no, undecided, and zip code. Those are ordinal. Now, next one is, not ordinal, I'm sorry, nominal. I keep making mistake here. So this is all examples of nominal. There's no inherent order here, right? So those are nominal. All right, next one is ordinal. Ordinals are categories only, but in this case here, categories have natural ordering system. There's a precise difference between the groups do not exist. So for example, how much better is good than average, right? And they're qualitative in nature. Now here, examples of ordinal are good, average, and bad. Another example will be a final grade A, B, C, D, E, F. And then a third example will be ranking of tennis players. Those are ordinal here. So common mistake for ordinal and nominal, students often confuse a nominal with ordinal, right? So if you're given a qualitative data, it could be nominal, it could be ordinal. And one commonly used will be, let's say, male and female. Male, female, right? So a student could be male, could be a female. And notice that there's no inherent ranking here, either male or female. Next one is interval and ratio. Now for interval and ratio, they both are quantitative variable. They are numerical in nature. Oh, highlight wrong one. They're numerical in nature. They're both numerical in nature. And they both are quantitative in nature as well. So let's talk about the difference. For interval variable, the data can be ordered, but there is no inherent starting point. Right? No inherent starting point. The choice of starting point is arbitrary. Now, ratio are meaningless here. A zero does not necessarily mean absence of quantity. Precise difference in ranking do exist. Now, for ratio, we say there is an inherent starting point, and zero does mean absence of quantity. So examples of numerical data would be like distance travel. Note that distance travel, zero, it does mean this absence of quantity here. 6 mile travel is twice longer than 3 mile. You can do a division here, notice that. So 6 mile over 3 mile give me 2. So meaning that 6 mile is twice longer than 3 miles. Another example will be a weight of grains of salt. Now 0 milligram, it does mean there's this absence of weight here. In this case, it probably means we do not have a grain of salt. And 10 milligram is twice as heavy as 5 milligram. Now examples of numerical data, let's say body temperature. And think about the temperature. 0, it does not mean there's no temperature. And there's arbitrary starting point. And I'll say 20 degrees Fahrenheit is not as twice hotter than 10 degrees Fahrenheit. Right? Now year of presidential election, time did not begin at 0 here. It's no inherent starting point. So it's another example with SAT score, right? So those are levels of measurement. Let me zoom in so you can see all of them together, right? Well, thank you for watching the video. I'll see you next time.